So looking at lesson 4, number 2, it says a motorcycle accelerates from rest. I would probably underline the word from rest. After 1.2 seconds, it's traveling 6 meters per second. How much time will have elapsed before the bike is moving with a velocity of 15 meters per second? So definitely, I think this question wants me to find time. I wrote down, I said from rest is good. And I said it looks like the final velocity is 15 because it says find the time when it's moving at 15. So I said this. Can I use that 1.2? Well, that's time. They want me to find time, so I'm not going to use that. Can I use that 6? Well, that 6 is after 1.2 seconds, so I can't use that. So I went, uh-oh, I only know 2 things. Mr. Dewick says I need 3 to find the 4th. What else could I use to find time if I knew it? I thought to myself and I said, you know what? If I knew the acceleration, I could find the time. Maybe from this, I can find the acceleration because that would be the same acceleration later on because they're holding the gas pedal down at a constant rate. So I said, okay, maybe I want to go, VI is still 0, T is 1.2, VF is 6. I can find acceleration. I can go A equals VF minus VI all over T. And once I find this acceleration here, I can move it to here, and I can use T equals VF minus VI over, I can use VF equals VI plus AT and rewrite that one. So this is a 2-step question. Okay? Don't panic. Don't start randomly guessing. If I sense it's a 2-step question, my high-tech organization is I draw a line down the middle of the page, or you can draw a horizontal line, but I usually want to try and keep everything on the same screen for me. I think number 9 was also a 2-step question. So if you go to number 9, I think you're going to have to find something and then find something. This one has 2 trips. So first, you'll find the distance from 0 to 5 in 4.5 seconds. Then you're going to travel at a constant acceleration for 8 more seconds. If you're stuck, I'll help you with this one either later today or Monday, but that's kind of a hint there. And there was one more 2-step one, but I can't remember which one it was. Also, 19 and the challenge are tricky. I'll let you wrestle with them, but if you're stuck, either later on in class or first thing on Monday, I can talk about these 2. Is that all right? Now let's look at lesson 6, Freefall. Example 1. We talked last day about G's. We said that anything over 10 G's, you're probably breaking a bone. Anything over 25 G's is usually fatal, although there's a wide range because we saw a video of Colonel John Stapp who handled 47 G's. And I think someone here asked me, so what's the biggest? This. In 1977, in Northamptonshire, England, David Purley's race car crashed, and his speed dropped from 174 kilometers per hour. No. How do I convert that? Is it divide by 3.6 or times? Divide? It's on your green sheet. So let's do that right now so I don't accidentally use that number. 174 divided by 3.6. 48.3 repeating. I'm going to write 48.3, but Aiden, I'll probably use my answer button. In 0.66 meters. So basically 0.66 meters is about this far. That's a whole meter, about that far. He went from 174 kilometers per hour to 0. That's a pretty big deceleration. He had 29 fractures, 3 dislocations. His heart stopped 6 times, but he did survive. Now, he didn't survive without permanent injury, but he did survive. This is the biggest G's survived that we have on record where we have the data. It's possible somebody survived more, but we didn't have cameras rolling in that car accident. This is what we have the biggest. How many G's did he experience? I will ask you to find G's on your test. How do you find G's? First, you find A. Then once you found A, you divide by 9.8. So, A equals question mark. What's that 48.3? That's a velocity. Yeah, which one? VI. What's that 0.66? I need one more thing, because that's only 2 things. I need 3 to find the 4th. Oh, what's VF in any car accident ever? I'm looking for an equation that has an A, a VI, a D, and a VF in it. There is one. You probably want your green sheet out. Which one? George. Oh, I thought you were going to looking up like you knew the answer. Sorry. I'll never assume you know the answer again. Oh, that came out wrong. Or did it? Alessio, which one? Yes. Get the A by itself. No. Thank you. VF squared. Keep going. So it's going to be 0 squared minus, I'm going to write 48.3, but you know I'm using my answer button. We're going to get a negative answer because he's most definitely slowing down. 0 squared minus answer button squared. Close off the top. Divided by, open up the bottom, 2 times 0.66. I get negative 1,769.78. I'm going to write negative 1,770 meters per second squared. How do I change that to G's? How big is 1G? Yeah, and it's on your sheet as 9.8. Negative if we want to have, a directional, but I'm not going to worry about that. The magnitude of this, divide by 9.8. If you want to, you can add in your notes now. Divide by 9.8. You only divide by 9.8 if I ask you to give me the acceleration in G's. If I just say find the acceleration, you'd be done. I'm going to round up because he's earned it, negative 181 G's. The negative G's is right. The negative, Aiden, you question or? Okay. The negative means slowing down. If you want, this is the equivalent then, because all of you are experiencing 1G right now of having 180 people dogpile on top of him. Yeah, George is trying to imagine. Not good. But he survived. So there's a lot of variation. I'm sure he was wearing a helmet and padding and, the racing suit. There was probably some kind of a seatbelt or harness system involved. Those are all variables that we just don't know about. But in general, usually anything over 25 is not a good thing. Okay. But all of you, if you've been to Playland, have pulled 2 or 3. And the biggest ride at Playland pulls about 4.5 G's. Now let's talk about Freefall. When an object is falling through the air, we say it is in free fall. Free fall is a bit of a bad term because if I throw something on its way up, it's still in free fall because the only force acting on it is gravity. That's really what we mean by free fall. In free fall, the only force acting on you is gravity, maybe a bit of air resistance, but we're typically going to ignore air resistance because air resistance is a really, 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 really tricky force. In free fall, as long as we're near the Earth, the acceleration is always negative 9.8 meters per second squared. We often use a lowercase g instead of an a for acceleration, just to let people know, hey, that 9.8 is from good gravity. Of course, that changes on other places. G on the moon is about 1.6. As you move further from Earth, G gets weaker. G on the International Space Station is about 9.2. I thought there was no gravity up there, Mr. Doug. What holds the moon in place around the Earth? So if gravity from the Earth can reach to the moon, do you think gravity from the Earth can reach to the International Space Station? Huh. So why are they floating? Food for thought. Put your pencil down, look up. We can now handle analyzing free fall. Example 2, I like example 2, I like example. In fact, really, I like pretty much every question in this lesson. Free fall's cool to me. A cannonball is dropped from a cliff. It hits the ground 10.6 seconds later. I don't know if you've ever stood on a cliff and dropped rocks. As long as you know nobody is down below, you can now figure out how high the cliff is if you time it with your stopwatch on your smartphone. A, how high is the cliff? First of all, note, dropped means that we know that VI equals. So anytime I use the word dropped, we can assume that. Max, what's A asking me to find? How high? In terms of our physics 5 variables, what's it asking me to find? And I already know that VI is 0. Max, what's that 10.6? How do you know? Yeah, you notice less and less am I putting the word time in front of the time or the word acceleration in front of the acceleration. I'm saying, look at the units, it'll tell you. Max, how many things do I know right now? 2. I need something else. V final's not 0. Trust me, do a belly flop onto the, it's not 0. I know one more thing. It's even in your notes. What about gravity? I know the acceleration. Negative 9.8. If we ignore air resistance, and a cannonball, since it's round and very dense, probably doesn't have much air resistance at all. Which equation? Why'd you waste my time? What's VI? So which special subcase modified version of the D equals VIT plus a half AT squared equation? And I usually write it as AT squared over 2. You can write it as 0.5 AT squared or 1/2 AT squared. And we need to get the D by, hey, great, already is. Negative 9.8, 10.6 squared, all over 2. If you're standing by a cliff and there's nobody down below and it's safe to drop rocks, the shortcut is time it, square the time times 10 divided by 2. And that'll roughly get you how high the cliff is. Wait, oh, my answer looks a little bit weird, Mr. Duick. Max, what's a bit weird about your answer? And that's because we haven't found a distance. We found a displacement. Did we end up above or below from where we started? The universe is saying, based on what you've told me, you better have ended up below from where you started. And we have. So I'm not going to get creeped out by that. I'm going to write negative 551. Is it negative 551? Yes? Meters. We don't call heights negative. Height is technically a scalar. So if in your final answer you said, oh, the cliff is 551 meters high, I'd clue in. But for what it's worth, don't freak out about the negative here. Actually, it comforts me. Yeah, I ended up below from where I started. B. What's the impact velocity of the cannonball? Kiana, what's this asking me to find? Velocity. Yeah, which one? Which velocity is B asking me to find? Initial or final? What do you think, folks? What is V initial if we're dropping something? Okay, so I'm going to go like this. VF equals question mark. Is VI still 0? Is T still 10.6? Is A still negative 9.8? I'm not going to relist everything. I could use my distance maybe, but if I can solve this without using an answer that I just calculated, then Fatima, I will, because that way if I got this wrong, I get this wrong. So, Kiana, which equation has a VF, a VI, a T, and an A in it? There is one. We need to get the VF by its... Oh, hey, that's a win. Oh, you wasted my time. What was VI? So a special subcase of this equation when we're dropping is just VF equals AT. So if you are dropping stuff off of a cliff and you're just curious how fast is it hitting the ground, time it times 10, roughly. 9.8. Negative 9.8, 10 point. That's how, if you remember, we did the little dropping activity from the ceiling a couple of days ago or yesterday. If you're wondering how I was able to say to somebody, that's way off, I was using these shortcuts to kind of get a rough guess in my head. And no, I know it's closer to this, not what you got. What's the negative telling me? What direction is this traveling when it hits the ground? So I'm okay with a negative. Negative 104 meters per second, which is pretty fast. Oh, this cliff is over half a kilometer high. We're at a high cliff. Go big or go home, right? Physicists. Max said, who just has a cannonball lying around? Physicists. C. What's the velocity of the cannonball after 3.6 seconds? Peniel, what's this asking me to find? Definitely a velocity. Which one, initial or final? What's VI whenever we drop something? It's in your notes. What's V? Yeah, so what velocity must this be asking me to find? If VI is 0, what's the only other option? Yep, so write down. Now, VI is still 0 because we dropped. What's that 3.6? What are the units next to that 3.6? You're still writing. Sorry, patience. Slow down, Mr. Dewick. What are the units next to that 3.6? What's the S stand for? So, what do we measure in seconds? I know you're away. I'm forcing you to kind of catch up in a hurry. Ethan, what do we measure in seconds? Time. Good. I only have 2 things. I need 3. Oh, A is negative 9.8. Coming back to you, Peniel. I'm looking for an equation that's got a VF, a VI, a T, and an A in it. There is one. You could always look at your own green sheet too, instead of Ethan's. So we're on the, was it third row or second row? Third row. Which one has a VF, a VI, an A, and a T in it? There's only one. Yeah. Yep. Keep going. Plus. Keep reading. VF equals VI plus. Yeah, I didn't hear you say the AT. Okay, I would actually say, what's VI? So did you need to read the VI? Since it's 0, we can do as our special subcase, say VF equals AT. It's going to be negative 9.8 times 3.6. Get your calculator out, Peniel. Once you've written that down, what do we get? Going to be negative, which again is good because it's on its way down. Now, in a bit, we'll look at what if you launch something up in the air. Sometimes you'll get a positive answer. It's on its way up. Sometimes you'll get a negative answer. Oh, it's changed direction and now it's on its way down. And the physics will all take care of that for you. Oh. Duick. Peniel, what'd you get? No, it can't get 35. Isn't it negative? It has to be negative, does it not? Oh! That's a silly mistake. That's throwing away marks. I can tell you right now, it's got to be negative. You get negative 35.28. So negative 35 point. And that's meters per second. Deegan, what's D asking me to find? Yeah, now I'm going to ask a favor. Whenever I'm asking questions, I hear several people whispering the answers to the students. You're not doing them a favor. They have to work through this on their own, Owen. Oh, did I say that out loud? Okay. So, by the way, technically it's not a distance. It's you're going to find a displacement because it's going to have a directional component. Above will be positive, below will be negative. D equals question mark. What else do I know? VI is 0. T is 3.6. A is negative 9.8. Which equation? So Deegan likes the 0.5 AT squared version. I'll go with that. I would have written it as AT squared over 2, but I don't care. Have we got the D by itself already? Yay! It's going to be 0.5 times negative 9.8 times 3.6 squared. I'm going to get a negative answer for displacement. What's this telling me? I ended up below from where I started. Or if you're not on a cliff, I ended up behind from where I started. Did you get negative 63.5? Now, again, if I ask you how far has it fallen, in English, you would say 63.5 meters. You wouldn't put the negative in, but if you leave the negative in your answer, in physics, it's more accurate, and I'm fine with that. Okay? So that's dropping an object off of a cliff. Let's throw an object off of a cliff. So first of all, let's throw an object from the ground, straight up, with a velocity of 29 meters per second. I like example 3, I like example 3, I like example 3. Example 3 is a nice question. Ariana, what's A want me to find? T equals question mark? What's that 29? Which one? Yep. Good. What else do I know? Oh, yeah. Are we in free fall? Even on the way up? A is negative 9.8. What else do I know? What's VF? Say that again, because you get a candy. What was that? So Ariana thought about this, and she realized that at the top, for a split second, right there, it comes to a stop, which means its velocity is what? Well played. I'm looking for an equation that has a T, a VI, and a VF in it. There is one. Can you get the T by itself, please? Yep. 0 minus 29 all over negative 9.8. Now we're finding time. We have to get a positive answer. I was a little worried at first when I wrote 0 minus 29 because that's negative, but then I went, wait a minute, it's going to be a negative divided by a negative. Time is positive, so I think I've got this set up right. Do you get 2.96 seconds? Cool. B. What's the maximum height reached by the ball? Riley, what's this asking me to find? Height, yep. Which physics concept would be associated with a height? Yep. Technically, we're going to get a displacement, and you know what? Since we're above from where I've started, I think I'm going to get a positive answer, I hope. So D equals question mark. I can still use the VI from the previous page of 29, and I know A equals negative 9.8. Oh, what was Ariana's epiphany? At the top for a split second, what's our velocity? And that's going to be VF. Putting you on the spot, Riley. I'm looking for an equation that has a D, a VI, an A, and a VF in it. There is one. Yep, can you get the D by itself? I'll give you a hint. D equals, shut up, Mr. Dewick, that's not a hint. Oh, okay. So what's going to drop down like a domino? The left side, which is VF squared. Yes, yes, yes. What's right next to the D? A 2 and an A? How will I move those over? Later. What else is on the same side as the D? A VI squared? How will I move that over? VF squared minus VI squared all over 2A. 0 squared minus 29 squared all over 2. How many of you, at least once as a child, spent some time throwing a ball straight up in the air as high as you could just to see how? Okay, so you ready? Just some interesting physics here. If you throw it faster, will the height get bigger or smaller? Be obvious. If you throw it twice as fast, because there's a squared, 4 times higher. If you throw it 3 times as fast, because there's a squared, 9 times higher. Little nerd trivia. Do you get 42.9? Units, Riley. What did we just find? Good. .29 meters per second, by the way. It's about 60 miles an hour. You've got a pretty good arm. You don't have a Major League Baseball kind of an arm, but people would say, oh, you can throw it pretty hard. C. What's the impact velocity of the ball just before it hits the ground? Aiden. Yep. Too slow. Owen, what's the impact velocity of the ball just before it hits the ground? Too slow. Max, what's the impact velocity of the ball just before it hits the ground? Not 0. Do a belly flop onto the cement from your desk. I assure you it will. But too slow. You should all know the answer. There's a saying. The saying says, what goes up must come. What's the impact velocity when it hits the ground? That's an acceleration. That's not a bad guess, but that's also a bad guess because you're guessing an acceleration for a velocity. What? So we can get your hand.
Meters per second.
If it left the ground at 29, it's going to come back to the ground at 29 because what goes up must come. That's if we ignore air resistance, and we are, and it's a cannonball. Now, what if you couldn't remember that? Okay. You would go like this. VI is 29. VF equals question mark. A is negative 9.8. What else do I know? By the way, put a negative in front of the 29 because it should be negative because it's velocity. It's going down. What do you know, Alessio? What's the distance? Okay, so one way to do this would be to start at the top, make the distance negative 42.9. Of course, I'd use my answer button. But then, if you're starting at the top, up there, what was our velocity? And if you solve that for VF, that'd work. You would use... Oh, wait a minute. What's VI? And then how do you get rid of a squared? Square root. And you would go 2 times negative 9.8 times answer button. Uh-oh. I got a negative here. And that's because I forgot to include the negative with my answer button. It said 42.9. And now this time it's negative because we're going below from where I started. So I'll just quickly multiply that by negative 1 to clear that, because that way I can square root. And I get exactly 29. Except, what did I say the answer was actually? This is that situation where when you take the square root, your calculator assumes you want the positive, and we meant the negative this time. That's one way. Or you could let VI be positive 29, A negative 9.8. Don't know what VF is. You could start on the ground. How high were you as a number if you start out on the ground? Be Captain Obvious. As a number exactly, if you start on the ground, your initial height is 0. When you hit the ground, what's your final height then? Still. So if you start at 0 and you end at 0, what's your displacement? And you can use... Oh, wait a minute. What's our displacement? So you would go 29 squared, square root. Oh, that works too. We've just reached the stage where you're going to have more than one option for some questions. You've just learned enough physics that now you can try several different approaches. But I'm going to be fussy. Don't guess an acceleration for a velocity, or don't guess a velocity for a distance. And my thing about units, I'm doing it on purpose, because if you put the right units in for the values, you'll probably stumble your way to a correct approach. But don't put wrong units, wrong values in for different concepts. Or what goes up must come down. But there's a couple of different proofs. Oh, square root. Okay. D. D. Nick, what's D want me to find? Okay. How? There's a short way and a long way. Can you spot the shortcut that we could use? Look up. Can you spot the shortcut we could use? If what goes up must come. Okay, if you happen to know how long it took to get to the top, double it. Okay? So, if you can do me a favor, draw a little line about 1/3 of the way over, because this is the shortcut. And I would use the shortcut if I'd found the time to top already. T equals, I'm going to say T equals T top times 2. Is that clear enough in your notes that we know what we did? Now, the only thing is that 2.96 is a rounded off value, so I might be a tiny bit off, but was it 2.96? I think it was. Yeah. So 5.92 seconds. What if I hadn't found the time to top? You could find the time to top. V final is 0, and double it. But that means doing an extra step. I'd like to get there in one step. What was VI? 29? What was A? What was VF? What goes up must come. I would probably use this, and then, Nick, I would say there's got to be an equation that has a T, a VI, an A, and a VF in it. There is one. Get the T by itself, please. Yep. So it's going to be negative 29 minus 29 all over negative 9.8. And so it wasn't actually 5.2, it was 5.9183673, well, 5.92 seconds. I don't care which of those methods you use. I'm fine with either. I would use this method if I had found time to top, but if I didn't know time to top, I'd rather get there in one step instead of finding time to top and then doubling it. I'm that lazy. Oh, Alessio, what was the displacement of the ball once it hits the ground? We're going to pause for a second. I'm going to take about a 10-minute break. You can just relax. I haven't given you new homework. You can work on homework for previous. You can work on the take-home quiz, but I'm going to stop because George is getting a little restless.
Oh, sorry.
It's okay. Here we go. So we dropped an object from a cliff. Then we threw a ball up from the ground. Let's combine them. So let's imagine you're standing on a cliff with your toes in midair. You're leaning forward in midair, and you're going to throw a ball straight up so that it's going to go straight up, and then it's going to come past you and keep going down all the way down to the bottom of the cliff. Does that make sense? Okay. So ball is thrown straight up from a cliff at 12.5 meters per second. By the way, what if instead of straight up, what if I threw it straight down? I wouldn't say 12.5 meters per second. What would I say? Negative, but I can handle it. The math will take care of itself then. It hits the ground at the base of the cliff after 8.85 seconds. Cool. Okay. Camille, what's A want me to find? Good. We're going to get a displacement, I'll bet you. Are we ending up above or below from where we started if we end up at the base of the cliff? We're going to get a negative answer. What's that 12.5? Which one? Yep. What's that 8.85? What else do I know? I don't know velocity final. It won't be 12.5 because it's going to rocket past my face at negative 12.5 meters per second, but it's going to keep speeding up, going down, going down, going down. So I don't know how fast it's going to hit the ground at, but I do know the acceleration. It's negative 9.8. I'm looking for an equation that has a D, a VI, a T, and an A in it. There is one. And I need to get the D by, oh, already is. And again, if I was being really fussy, I could put a vector sign because we are getting a displacement with direction, not a distance. The distance would be all the way up plus all the way down. Who cares? Displacement. So it's going to be 12.5 times 8.85 plus 0.5 times negative 9.8. And usually students ask, Mr. Dewick, don't we have to somehow, like, isn't this going to, how is this going to give us the displacement? This first part is on the way up. This second part is from the top all the way down. And so it takes care of it for me. It gives me then the distance from my feet down to the ground, the height of the cliff. What'd you get, Camille? Negative 273? Is she correct? Anybody else? Yeah, did she round off properly? Yeah, okay. B. Problem, what's B want me to find? Well, it says maximum height. So in terms of a physics concept, what's it want me to find? Yeah. Okay, now we got to be a bit careful. We're at the top. So what do we know here? Is VI still 12 points? Yeah, I think the VI is still good, yes? And A is still negative 9.8. What else do I know? What else do I know? Yeah? At the top for a split second, VF is 0. Or if I decided to start on the top and work my way down, VI would be 0, and I could work some magic there too. If I can start wherever I want, really. A problem, I'm looking for an equation that's got a D, a VI, an A, and a VF in it. There is one. Can you get the D by itself, please? It is the VF squared one. Yeah, I got that. Good. So it's going to be 0 squared minus 12.5 squared all over 2 times negative 9.8, which is what? By the way, Prabnur, are we expecting a positive or a negative displacement right now for this one? Are you positive? Sorry. Did you all get 7.9719, 7.97? And this is wrong. For a candy, who can tell me why this has to be wrong? Sorry? Because of the negative? No, we're okay with that. What? What we found is how high it went above where our feet are, the cliff. Ah, candy for you, my friend. So I'm going to use h for height. That's going to be 7.97 plus positive 273 if I go from the ground up. The actual height of the cliff is going to be 281. Sorry, the actual height of the ball is 281 meters above the ground. What we found was its displacement from where it started, but that's not really what this question asked. So that's why you kind of got to interpret the questions a little bit. I'm going to pause. Keep going. What C you want me to find? VF. In terms of our physics concepts. Is it 0? No, after it hits the ground it's 0, but VF is not 0 when it hits the ground. So let's make a little note here. VF equals 0. No, VF equals question mark, 0. VI was positive 12.5. I know A was negative 9.8. What else have they told me? Oh, 8.85. Annika, I'm looking for an equation that has a VF, a VI, an A, and a T in it. There is one. And I need to get the VF by, oh, ha, already is. Are we expecting a positive answer or a negative answer here? Which way are we traveling when we hit the ground? I'm hoping to get a negative answer. Let's find out. 12.5 plus negative 9.8 times 8.85. Again, make sure you're typing these in to follow along. It's an easy way to get good at your calculator. You get negative 74.23. So I'll call it negative 74.2. Okay. Which I'm okay with a negative. It's when we're using the VF squared equation and we square root, we always have to ask, okay, was I traveling up or down? Maybe I wanted the negative answer that my calculator didn't give me. Next page. I don't like example 5. I don't like example 5. I keep forgetting to delete it.
Why?
I like example 6. I like example 6. I like example 6.
This is tough.
This is physics 12 easy, physics 11 tricky. And you'll see why in just a second. I'll pick on George because, you know, George, what's, so a ball is launched straight up from the edge of an 82-meter high cliff with an initial velocity of 18 meters per second. How long until it hits the ground at the base of the cliff? What's this question asking me to find? Yes. What's that 18?
Initial velocity.
And we're in free fall, even on the way up, so A equals negative 9.8. What's D? I'm going to give you a hint. It's not 82. This is the first little mini curveball, not 0. You need to realize that this is technically a displacement. Does this end up above or below us? So what's D? It's not 82. So the first thing you have to catch is that, which is a tricky catch, because that's one that might not show up on your calculator in that you might not get a math error or a glitch on your calculator. Sometimes you do, sometimes you don't. George, I'm looking for an equation that has a T, a VI, an A, and a D in it. There is one. Oh, sorry. And I heard Max murmur to himself, there's two t's, and unfortunately, none of these are zero, so one of these t's does not vanish. Right now, you can't solve this. Who are my math 12s? You could make this equal to 0, plug things in, and use x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Or you could use the quadratic solver that many of you now have in your calculator. However, by grade 11s, that was all gibberish. So, but George, how many things do I know? Then I can find a fourth. What else could I find? If I can't find t, what else could I find? Which v? I can find vf, and maybe I can use that to find t and avoid this. So I'm going to say find vf. George, is there an equation that has a vi, an a, a d, and a vf in it? I need to get the VF by itself. It already is. No, technically, no. So VF is going to be the square root of 18 squared plus 2 negative 9.8 negative 82. Did you remember to take this?
Oh, no, I didn't.
What'd you get?
40.
Nope.
What did I say? 40.
What'd you get? Nope. What'd you get? What? I have to, again, this is why this is such a tricky question. There's so many little mistakes you can make. You can miss that the displacement is negative, and you won't find out by getting an error on your calculator necessarily. And then even once you've done that right, you have to realize my calculator is assuming I'm on my way. I'm on my way down. So negative 43.9 meters per second. Now, if I want to store that on my calculator, how can I make that negative so I can use my answer button? Times -1. There. Now it's negative. Okay. Ready, George? You see, the problem, look up, don't write this down, was that, because I can't use that equation. So, is there an equation that has a t, a vi, and a vf in it? Can you get the t by itself, please?
T plus VF.
So I'm going to write -43.9, but I'm going to use my answer button. Minus 18 all over negative 82. And the nice thing is, grade 12s, if you use your answer button all the way through this method, you'll actually get exactly the same answer as the quadratic formula to an infinite number of sig figs. It'll be bang on. So, you already has, thanks. Answer button, minus 18 divided by negative 9.8. 6.32 seconds. That's the workaround to solving this equation because you don't know the quadratic formula. You can still get the t by itself, but you do it by finding something else first and using a simpler equation. But it works. What's your homework? You can try number 1. 2 is good. Never mind. Skip 2. You know what? Let's do this. Skip 1, do 2. That works. 3 is good, so skip 1. 4 is good. 5 is good. 6 is good. 7 is good. 8. You can skip 8. 9 is good. You can tell I typed this up back when Roberto Luongo was a goalie for the Canucks. 10 is good. Put a star next to D. I haven't talked about this. That's my, I wonder if someone can figure out, aha, how to get it. Okay. Skip 11. 12 is good. 13. 14 is good. Skip 15. 16. Skip 17. I already did one like that. Skip 18. You can try 19.
Where's 20?